Math 230, Cuesta College. I'm Joe Vasta, and we are covering section 6.3, counting numbers. Consider 4-digit whole numbers to be formed using the digits 1, 2, 3, 4, 5, 6. 4-digit numbers. So some of those 4-digit numbers are, let's do some examples over here. Could be like 2,635 or 1,254 or 3,434, etc. How about 4,126? So there's a lot of these numbers, and we're going to count these numbers, and we will look at repetitions are not allowed, repetitions are allowed. You might be able to do these first two problems. Before we get to that, the puzzle for this lecture is this. Figure out what goes in the box. A2, B0, C2, D0, E3, etc. And my guess is probably going to be that there's going to be an M, but what number follows that? Okay, and could you even do the next one? So the hint to this one is the fact that since you guys have been taking this class, you're more likely to get this puzzle than the average person. Okay, so there's the hint. Let's go ahead and do counting numbers. So with counting numbers, how many different numbers can be formed if repetitions are not allowed? Well, here we have 4-digit numbers. Now in your homework, it might be different. It might be 3-digit numbers. So make sure you read the instructions carefully. And reps are not allowed. So we start off right here. We say how many different choices do we have for this first slot? And there are 6. Repetitions are not allowed, so let's go ahead and put one of the numbers there. Like, let's put a 5 there. We cross it off the list there. Well, now having used one of our choices, how many choices do we have here? We have 1, 2, 3, 4, 5. We have 5 choices here. Let's put a 1 there. Cross that off the list. Now, why am I crossing things off the list? Because repetitions are not allowed. Now, how many choices do I have for the third slot? Well, 1, 2, 3, 4. And so let's go ahead and put maybe a 6 there. Cross that off the list. And so I have how many choices for my last slot? 1, 2, 3. 3 choices. Put a 3 there. And perhaps we can put a 2 right there. Now the green thing doesn't really matter. That's just one of the many numbers that I'm counting. Okay. What matters is what happens below. 6 times 5 times 4 times 3. So 6 times 5 times 4 times 3. So what I'm going to do is I'm going to go 4 times 3 is 12 times, then we have 6 times 5 is 30. We have a 0 there. 3 times 2 is 6, and 3 times 1 is 3. So it looks like my final answer for this, how many different numbers can be formed if repetitions are not allowed? They are 4-digit numbers, and you're using these guys right here, 360 for the first answer. So 360 would not include this 3,434. That would not be included in there. But This one, anywhere where there's no repetitions would be included. Okay, and the green one as well. So now how many different numbers can be formed if repetitions are allowed? So now we're opening it up to repetitions. Are numbers going to be bigger than 360? And so let's do this problem here. 4-digit whole numbers. How many choices do I have for the first slot? I have 6 choices. Because I've crossed some of them out for the last problem, but there are 6 choices, and then there are 6 choices again, 6 choices again, and 6 choices again. So I have 6 times 6 times 6 times 6. So I'll do that off right here. So 6 times 6 is 36 times 6. So we have 36, 18, 19, 20, 21. Okay, and then I have to multiply by 6 one more time. 36, carry the 3, 6 times 1 plus 3 is 9, and then 6 times 2 is 12. Whew. Okay, so this one gives me 1,296. And yes, when you allow for repetitions, it's going to be a bigger number than when you say, hey, there's no repetitions. So some of you might be thinking, well, this is just like 6.2. when we were counting words. Some of you will find this to be the same or simpler than 6.2. But in any case, there's probably a lot of you thinking, well, this is just dumb, Joe. Why is this important in the world? And in 6.4, we're going to see some real world applications with license plates, social security numbers, phone numbers, things like that. But we have to learn how to do the basics before we get to the applications. Let's go ahead and do another pair of problems here. How many different even numbers can be formed if repetitions are allowed? So there is a restriction. Even numbers. Go back over here. This number right here, 2,635, is that even or odd? Well, that's odd. Why? Because of that 5. 5 is odd. 1,254, that's an even number because the last digit is even. So when they say even numbers, the restriction is on the last slot. So let me go ahead and put 4 slots up here. Because it's an even number, we're going to go like that. Okay, so this has to be an even digit. Which would be 2, 4, or 6 in this case. So how many choices do you have for your restriction? You have 3 choices, 2, 4, or 6. But repetitions are allowed, so what we're going to put under the other 3 slots, we'll put 6s under those. And so we don't have to like write things off and cross them off because reps are allowed. So 6 times 6 times 6. We did that in the last problem. That was like 216. I'm going to multiply that by 3. That's this 3 right here. So 6 times 3 is 18. 3 add 1, 4. And then 3 times 2 is 6. So the answer to problem number 3 is 648. And at any time you could just pause the videos when you see the problems and see if you can do these problems on your own, like maybe number 4. So problem number 4, we have a 4-digit number. It has to be even, which means the restriction is right there. So this has to be an even number. What makes the whole number even is if the last digit is an even digit. This is repetitions are not allowed, so I'm going to be using green and crossing things off this list. So how many choices do I have for that slot? Well, it starts off like the last problem. There are 3 choices. You can put a 2 there, a 4 there, or a 6 there. So I'm going to go ahead and put a 4 there. Now it's very important, and we said this last time, that you do your restrictions first. Okay? We'll talk about at the very end of this problem if you hadn't done that. So there were 3 choices. We went ahead and put a 4 there. Okay, now how many choices do I have for this first slot? Well, I have 5 choices. So I'm going to go ahead and put a 1 there. Now, you might be thinking, well, where did you get that from? I just picked one of those randomly. So 1's a good thing to put there. And now I go to the second slot. How many choices do I have for that second slot? Well, 1, 2, 3, 4. So perhaps I'll put a 6 there. We'll cross that off the list. Okay, now how many choices do I have for this third slot? I've already used up 3 choices. Do you see that? So 1, 2, 3 left. Maybe I'll put a 2 there. What's in green is not really going to get you the answer. It's just one of the things that we're counting. This is the answer right here, which is 5 times 4 times 3 times 3. 5 times 4 is 20. And 3 times 3 is 9. So it looks like my answer to this is 180. Okay, so that is how you do these problems. You may see that, so here are some things that people notice when I teach this in class, is that 180 is half of 360 and 648 is half of 1296. And we were picking even numbers for these guys. Well, yeah, that happens here, but in the homework and on the test, you might have 1, 2, 3, 4, 5 only, or 1, 2, 3, 4, 5, 6, 7, and then it won't always be half. Okay? If you don't know what I was talking about, then just ignore that last part. We go ahead and do the next 2 problems. So it might be good if you paused the video. See if you can do these problems. Well, let's take a look at problem number 5. It says, how many different numbers divisible by 5, that's your restriction, can be formed if repetitions are allowed? So reps are allowed, divisible by 5. Which of these numbers here happens to be divisible by 5? Well, the top one, because the last digit is a 5. Numbers that are divisible by 5, you can see them because their last digit will be 5 or their last digit will be 0. Now, we can't allow for 0 because those are our choices. So our restriction is going to be on the last digit. So having said that, let's put our 4 slots. Our restriction is right there. That absolutely has to be a 5. Now, if that's going to be a 5, I do my restriction first. How many choices do I have for that? I have 1 choice. I did say something, so some of you are getting annoyed about me putting old problems up here. I said I would go back and consider what would have happened if we didn't do the restriction first on this and we just put a 6 and then a 5 and then a 4 and then a 3. Well, 6, 5, 4, 3 would give me something greater than 180, and by putting a 6 here, you're saying that you could be using up all your even digits here and not have anything there. So you don't want to say, I'll do my restrictions last, and I always do them first. It matters when repetitions are not allowed. It doesn't matter as much when repetitions are allowed, but I just do my restrictions first. So there's one choice there. Repetitions are allowed, so what goes under each of the other slots? Well, I have 6 choices here, and 6 choices here, and 6 choices here. So 6 times 6 times 6 times 1. Well, we've already done 36 times 6, and we already know what this is going to be. This is going to be 216. So that answers that question. Now, how many different numbers divisible by 5 can be formed if repetitions are not allowed? So these are the ones that are a little more challenging when reps are not allowed. So there's my restriction. Divisible by 5 must mean there is a 5 here or a 0 there, but 0 is not allowed. You know, those are my choices here. So I have to put a 5 there. So how many choices do I have for that? Just one choice. I put the 5 there. Doing my restriction first. Okay, now how many choices do I have for that first slot? 1, 2, 3, 4, 5 choices. So I'm going to go ahead and put 6 there, I guess. How many choices do I have for the second slot? I have 4 choices. I'm going to put a 1 there. And how many choices do I have for this third slot? Well, looks like I just have 3 more choices. And let's just put 4 there. So to get my final answer, I'm going to go 5 times 4 times 3 times 1. 5 times 4 is 20. 20 times 3 is 60. So there are 64-digit numbers from these digits that are divisible by 5 and reps are not allowed. And one of these 60 numbers happens to be this green one here, 6,145. Let's go ahead and see if we can do the next one. And maybe you can pause the video and see if you can do these on your own. How many different numbers less than 3,000 can be formed if repetitions are allowed? So we're allowing repetitions. Our restriction, the number has to be less than 3,000. So you can think about that. Where would that be? How do you see if a 4-digit number is less than 3,000? So we'll bring back these guys here. Is 2,635, is that less than 3,000? The answer is yes. What are you looking at to see if it's less than 3,000? The first digit. 1,254 is less than 3,000 because there's a 1 there. 3,434 is greater than 3,000. And we knew that because there is a 3 there and a 4 there. That's greater than 3,000 as well. So your restriction is in the first slot. And this has to be what? What digit can you put there? How many choices do you have? You can put a 1 there or a 2 there. So once you put a 3 there, I mean, you're just using these digits. You know, the next number you can put there that's the lowest is a 1, and you're already above 3,000. So you have 2 choices. I'll put right above 1 or 2. And since repetitions are not allowed, repetitions are allowed, I'm not going to write up the other ones. I'm just going to put 6s under those slots because you can go 1 through 6 on each of these guys right here. So we've already seen 6 times 6 times 6 in problem 2, which was 216 times 2. So 12, and then 2 plus, we have the 3, and then we have 2 times 2 is 4. So my final answer for this is 432. How many different numbers less than 3,000 can be formed if repetitions are not allowed? So this is less than 3,000. 4-digit numbers. The restriction, as we talked about in the problem above, is the first slot. That could be a 1 or a 2, so I have 2 choices. Doing my restriction first, 2 choices. And it has to be less than 3,000. So I'm going to go ahead and, let's see, eeny, meeny, miny, mo, whatever. I'm going to put a 1 there. Okay, repetitions are not allowed. So now I have to figure out how many choices I have for the second slot. Well, 1, 2, 3, 4, 5. I have 5 choices. So I think I'll go ahead and put 6 here. And now how many choices do I have for this third slot? 1, 2, 3, 4. What do I want to put there? I'll put a 2 there. And how many choices do I have for this fourth slot? I have 3 choices. 1, 2, 3. So I'll just put a 5 there. So this looks like this is 12 times 10, which is a 12 with a 0 after it. There are 120 4-digit numbers using these digits that are less than 3,000 and repetitions are not allowed. 120 of those. And 1,625 happens to be one of the 120 answers. But we don't have to list them all out, thankfully, because that would be listing out 120 answers. We just have to say how many there are. So that's how you do problems 7 and 8. We're almost done with this lecture here. We're just going to do 2 more problems, 9 and 10. How many different numbers less than 3,000 and divisible by 5 can be formed if repetitions are not allowed? Wow. Okay, so this is crazy. There's actually 2 restrictions less than 3,000. And I'll just actually use orange for the other restriction, divisible by 5. So let's put this up. Less than 3,000 means that slot has to be a 1 or a 2. Divisible by 5 means this last slot has to be a 5. We do our restrictions first. So how many choices do I have for this slot right here? I have 2 choices. And so, you know, I guess I better pick one of these because this is reps are not allowed, so I'll pick the 2. So I just picked the 2. I'll put a 2 there. How many choices do I have for the last slot? 1 choice. So I put that there. And so because reps are not allowed, I'm going to cross out the 5 and cross out the 2. I'm not going to cross out 1 and 2 because I had to pick one of those. So I just picked the 2 and I picked the 5. But I am doing my restrictions first. So there were 2 choices here, 1 choice there. Now, let's do second slot. How many choices do I have for that slot, having used 2 of my choices already? Look, 1, 2, 3, 4. Okay, so why don't we go ahead and put a 6 there? So it says 2, 6, something 5. So 6 there. Now, how many choices do I have for this third slot? Just 3 choices. 1, 2, 3. I'll go ahead and put a 1 there. So we multiply these numbers together. 2 times 4 times 3 times 1. So 2 times 4 is 8. 8 times 3 is 24. There are 24 whole numbers that fit the description here. One of those 24 numbers is 2,615, the one that we have in green, but this is my answer right here. One more problem to do in this section and then we'll get to the puzzle. It's the same type of problem, except repetitions are allowed, which in some ways makes it a little simpler. Less than 3,000. Okay, so I have my 4 slots. Restriction on the first that says it is less than 3,000, so we have a 1 or a 2 here. And then this one is divisible by 5, which means you must have a 5 here. And 0 is not an option, so we don't have that. Repetitions are allowed, so we have 2 choices here, 1 choice there. It kind of starts off the same as the problem above, but this one's going to be different because we have all of our choices right here, all 6 of them right here, so there's a 6 there, and then all 6 of them right here, so there's a 6 there. So on this one, it looks like I have 2 times 6 times 6 times 1. This is 36 times 2. 36 times 2 is 72. So these problems got complicated. If we had said greater than 3,000 and divisible by 5, then there would be some overlap on those. This would be inclusion, exclusion, and it would get a little bit more complicated. We are not going to do problems that are that complicated. So we kind of like, when we have problems this complicated, we have some choices here for this restriction and some choices here for this restriction. They will never overlap. But in the real world, it's possible that there is some overlap, and then you've got to do more complicated calculations. So that finishes the 10 problems that I was planning on doing for section 6.3. Our puzzle. So you might not like the answer to this puzzle. The answer to this puzzle is, well, let's see if we can do this. Remember we did graph theory, and we did if things were traceable. So let's look at the letter A, the way we have it there. If you go to put your vertices here, and you label them, look at this. This one gets a 1, 1, and then 1, 2, 3, 3, and then this gets a 2. Okay, so I would pause the video if you're interested in doing this and try to do that with some of the other letters and then see what's the significance of this number here, 2, and then for B, 0, and then for C, 2. Where are those numbers coming from? So if you're like curious and you want to do this, then pause the video. I'm going to just start doing this. So here's the letter B. Okay, so we'll call that a vertex, and that a vertex, and that a vertex. So we have 2 there, 1, 2, 3, 4. I know you're thinking, hey, well, is it traversable? I don't care about that. I'm just labeling these. So there's just all even numbers on that one. And then C, well, we do have a vertex there and a vertex there. So this one gets a 1 and a 1. So this one gets A2 and A2. So what significance do we see? I mean, here, there's like a 2 there. What is that? 0 there, 2 there, and then 0 there. Let's look at E. I think by the time I put E down, you'll go, oh, I see. So I'll put some vertices there. And so because E has a 3 there, let's see. 1, 2, 1, 2, 3, 1, 2, and then this has 1, 1, 1. So we end up getting 3 there. And I didn't do it in red, that's all right. So what do you notice about 3 here? Well, you might have picked up on this. We'll just use this right here. That this 3 describes the number of unattached endpoints, are the ones that have the number 1. So here, none of them had the number 1. Over here, look at this. 2 of them have the number 1, and here none of them had a 1, and then 2 of them here have 1. So if you're like interested in the 4, look at the 4 like this one. There's a 1, there's a 1, there's a 1, there's a 1. So 4 of the vertices have a label of 1 on them. Or you can say 4 of them have there are 4 unattached endpoints on that. So let's look at the letter M, so we know M's going to be in there. So how many vertices on that have just a 1? Well, it would just be 2. And so some of you may not have liked that puzzle, but it is what it is. There's no taking it back now. It's on YouTube. Do your homework, and I'll see you in the next video.